Right, a quick review of the LIDL Ledvance bulkhead lights on sale this week in the right at the end of 2019. 6-watt bulkhead light. No idea what the size is from the picture, but it's actually quite small. I have had it out of the box, but I haven't reviewed it yet or taken it apart. It shows you a picture of it inside a garage, which is fine. But the implication for a bulkhead light is that it can be fitted outside and on a wall or somewhere. And does it state the IP rating? So the first thing to look out for, I thought I'd put this outside, and they seem to have taken some steps to make it useful outside. But yeah, so here it says, so for a start, look, 6-watt bulkhead light, so they're claiming 6 watts, LED 4000K is like white daylight, and IP54, so they're not claiming it to be waterproof. IP54 is not waterproof at all, okay? 5 is a dust and 4 is the waterproof rating, so I think it's splash proof. That's all it is, it's just splash proof. So it's a bulkhead light to go outside, it's not rated, and 5 is a dust rating, so the dust can get inside. So I'm surprised, you know, basically if it's in a big dusty environment, the dust doesn't get inside the unit. So it's a bit strange. And also it says 6 watts here, but if you swivel it over this side it says 5.5 watts. So inconsistency in the packaging, okay. OSRAMlamps.com. It's not made by OSRAM, it's made by these people, and they have a license with OSRAM, so OSRAM should have approved this product. The other thing you'll note here is that this power rating, or the efficiency rating, they haven't stated what this light is. They just said that the LED could be A star star, A star, or just A. Now they're supposed to say what this one is, because it is very clear in the regulations about which light is which and what constitutes an efficient light. So that's a breach of the requirements, actually. I have very good contacts with OSRAM, because I buy a lot of OSRAM LEDs for horticultural lighting, so I'll mention that to them. IP54 again there, and it's neat. Alright, so why is it IP54? It's a strange rating, that, because I'll show you when we have a look inside. I've had a brief look at this thing, very brief. And there's a load of stuff here. Made in China. So it's Chinese. Yeah, so I don't know. What do you think? I think it's a bit of a disingenuous Chinese packaging, to be honest, to have an OSRAM label on it. I'm sure OSRAM have something to say about that, but I'm willing to listen to what they've got to say. Right, so let's take her out of the box and have a very quick review, just so that you see whether you want on these things or not. So there it is. Get the old ruler. You can see that's how long she is. 160 by 90, right, 160 by 90, plastic, sort of textured plastic top, and CE label, and here it says 5.5 watts, so the box is wrong. The box is just misrepresenting. They rounded it up by what's 50 and 60, is that that's 0.5, and that's 8% too overrated on the box, which is not good. 8 to 10% misstated. And it's got Germany, so it's leading to believe that the Ledvance GmbH is a German company, but these are definitely manufactured in China. So it's a German design, and it's got a little nice sticker on there, look, for some voltage going in. And if I just show you, what did I do with that bit of cable? Oh yeah, so first thing is, most UK households will be wired with this kind of cable. This is 1mm twin and earth lighting cable, and that's, if you've got an older house, it might be 1.5mm, because of they used to use filament bulbs, but they generally tend to wire up house lighting with 1mm now. And yeah, so that's what your house will probably have. And if you look at this seal hole, this is designed for a round cable. It's a pliable rubber seal, look. And if you shove the 1mm in there, straight away you've got an air gap, right? So any integrity as far as moisture is concerned is going to be ruined by that, alright? So bad design of the seal for the UK market, unfortunately. they're only rated it, to be fair to them, they've only rated it at IP54, so it wouldn't affect it. But I'm wondering if anything, all the other parts of this thing would be waterproof or not. So let's have a look at it. Okay, so you've got your two brackets to mount it on the wall. Also looks like it implies there's a hole there for a screw to come through from the inside, but I don't know what that's for. I think that's just a spacer to make it stand level with this, but there's no access to this unless you take it fully apart to put the screw in. Alright, so that's a bit of a strange artifact from, probably they've reused this backing from an old product, I should think, the way it tends to go. So let's whip the old wiring cover off. Four non-captive screws in a cover. No recycling marks on the cover. And we've got a little chocolate block down there. In there. And they seem to be, yep, they're tightened down and the ends of the wires have been crimped. So that's really good quality. Nice flexible wires. They feel like silicone actually, so quite a good wire there. And you've got a strain relief clamp there and live and neutral, which matches up with the thing, so that's good. When you finish with it, you can put it down onto this peg down there. Alright, so clamp, not bad at all. There's the end of my rubber thing. Maybe I've misjudged that actually. Oh look. I'm not sure. I'm not sure whether you're supposed to cut a hole in that yourself, but it doesn't actually go through to anywhere. So I'm guessing you're asking you to snip that off at a certain height or width. So it may seal, but yeah, not great, eh? Would be better with much more of an adjustable seal where you put it in and then tighten down on the seal so it seals around the cable. Yeah, I'm not sure if you slice that off. You can see it about to give up the ghost. Whether you're supposed to push that through or whether you're supposed to cut it off. What does it say in instructions about that? Ah dear. Yeah. So it's this one here. We got the 5.5, not the 6 what it says on the box. Misleading, misleading, misleading. Power off, power off. Drill the holes, shove in the wire, round wire from Germany, not an oblong wire from the UK. It don't really say, does it, about what you do with that seal, whether you expect to cut it off or you expect to just to roger it and it go right through. Coming through, just the tip and just for a minute. No, I don't know. What do you think? I can't see anywhere where it says slice that off. We'll try chopping it off in a minute and see what happens, see what kind of seal it makes for us. Clearly if you're mounting this outside and you do decide to put it outside, you need to mount it upright so that any water runs down and out rather than having that way of water runs in through this weird seal arrangement. Weird one that, isn't it? Makes you wonder. Come on out, you'll come. When you went in, you'll come out. Yeah, there's the aforementioned seal. It's got a nipply bit look, and a thin bit there, look. What? Hello? No, I don't know what that's for. Let's cut that off. Let's snip her off. Where's my scalpelizer? There we are. So she's got a hello boys. And if I push this through, this is, oh yes, I'm coming. There we are. Well, yeah, well, maybe the seal has redeemed itself. If you snip that off, look, that's gonna, provided it doesn't relax too much, provide a reasonable seal, isn't it? So that's what you do with that, boys. prolapsing somewhat. There we are. That was quite satisfying. That was weirdly satisfying, worryingly satisfying I should say. Right, I should get out more, shouldn't I, instead of making these bloody videos. There we are. Get back in there. I wonder who's got the lucky job of putting this in at the factory. Ming the Rogerer probably. Look at that. No starters at all, straight in there. Perfecto. There we go. She's back in. Alright, so let's take her apart and have a look inside. And then we'll fire her up, shall we? Check the power factor and check the power, the actual power, using the old Yokogawa. Very good power meter. The Japanese are coming, boys. Of course, after Brexit, we'll have our own precision power meter manufacturers rather than buying Japanese. Dream on. There'll be some sort of mediocre management stroke investor who are not willing to bloody invest any money in any products without a return within 5 minutes. So I got these dogs around there, woof, and just need to push them out. These, I've never known what to call these things. You know, these what do you call those? A barb, I suppose. Hello, Barb. So what we've got here, we've got the plastic. It's not that actually transparent. I think that's probably going to be knocking out a lot of your light. We'll check that in a minute. We've got a radiometer, so we'll see just how much light this is actually absorbing. It's not very bright. If I put that over the light, yeah, maybe, I don't know, we'll see. Quite a shadow under there though. I reckon that's 30% of the light's being lost on that. And then you have got, look. This is held in like that, but you can see on this bit there is a rubber seal in here. Is it rubber? Let's pick away at it and see if it's rubber or foam. It's a soft, yeah, it's a foam rubber. I don't think it's polyurethane foam. It feels like a very soft silicone. So there is a seal there, and certainly that would act as a dust seal, but I'm not sure about for a pure moisture seal. So that's the top part. And then in here we've got, how many leads we got? 1, 2, 3, 4, 5, 6, that's 12, 22, 23, 24, 25, 26, 27, 28, 29, 30 leads, right? So we've got 30 leads. And you can see this is one of those metal substrate PCB boards, so it's an aluminium sheet with a very thin layer of PCB material stuffed on top. And can you see that little mark down there? That little mark down there. See that? Oh, sorry. As usual, going too far. We've got a little fiducial dot there and a fiducial dot at this end, and that's the camera on the surface mount machine. Takes a picture of that fiducial as a targeting thing to make sure that the board's lined up before it starts stuffing these chips on willy-nilly. They all look soldered alright actually. I wonder if they're actually OSRAM chips. They may have pulled a fast one here, the Chinese, and put non-OSRAM product in. That would be a scandal, wouldn't it, for OSRAM. So let's whip these screws out. 3 little screws holding on the top. 1, 2, and number 3. Number 3. Okie dokie, picking a pokey. Right, so there's your aluminium thing we bought. Can't see much wrong with that really. That's not going to get very warm as if it's just 5.5 watts of power. It won't be 5.5, it'll be 5 by the time it's been through some crappy power supply, I expect. Again, nice silicon flexible wires, so not bad so far, boys. And then the power supply. What have we got here? Nice little power supply. Okay, let's have a look at the power converter. What have we got? We've got the mains input wires. They're nice silicon wires coming in through this fusible resistor. I'll just turn the soldering iron on. Do you know what? I usually have a fuse or a resistor, but calling it a fusible resistor, I doubt there's any spec on this datasheet about the blowing characteristics of this as a fuse. But what happens if there's a catastrophic failure on this side, either the capacitor, the chip, the offline buck regulator chip, or say the bridge rectifier goes short, then you get a mains input and a cathode, and it just blows the resistor open. Okay. Then they've put a place in for a variable resistor there, which is a varistor, which is a resistor which starts conducting at a certain voltage. It's a voltage dependent resistor. And so the theory is if you get a surge coming down the mains, that would start conducting and protect the electronics from the overvoltage situation. They are very effective. They're no good if you've got sustained overvoltage, because they will quickly overheat and then turn into a little flare and burn out. They're a sintered pellet of metal oxide. But they've decided to, in the interest of cost, they've left it out, right? Which is not good, really. Then we've got underneath, presumes a bridge rectifier. Yeah, there's the bridge rectifier, look. So that's a full bridge rectifier. And then we've got a 5.6 microfarad 400 volt capacitor, which is the reservoir capacitor for the high voltage side. A coil, that's a high, gives a high impedance to any switching noise from this side going back down and being radiated out the mains cable. So there's a, if you like, an HF block inductor there. And also there's this capacitor directly across the mains, yep. So that's, is that class Y? 0.2 to 400 volt. That will make the power factor worse, actually, but it's put in there as a high frequency shunt across the mains, again to stop the irradiated switching noise being blasted out of your mains cable in your house and potentially interfering with any of your kit, you know. But yeah, I mean, why put that there? Jesus, that's going to make the power factor much worse. Yeah, and so you got your what's that, 400 volt? I'd like to see a 450 in there. My mains is 245, which peak gives you about 254 volts. So you can sorry, 354 volts. So that on mine should be about 350 volts, I think. And yeah, it doesn't take much of a surge to go over the 400, and these get quickly damaged if there's an over voltage. There's the buck regulator chip, offline switcher. Can't see the number, I'll look it up in a minute and maybe go through that as anything of interest. And then a couple of diodes, and then output rectifier somewhere. Is that the output rectifier? Yeah. And then a reservoir capacitor, which is at 2.2 microfarad, 3.3 microfarad, 400 volts. Yeah, so that's I don't know what this chain's going to be. This will be either 2 or 3 chains of lead, so they'll be series parallel or parallel. Yeah, series parallel, 2 or 3 chains all connected across the supply. So here it could be anything between 60 and probably 120 volts DC. And then the little coil, and it's a buck coil, but it has got yeah, it's only two pins are connected, that one and that one, so it's just a coil, right? So this is reference to mains. This is not isolated from mains, but it doesn't need to be. It's inside a plastic housing, right? So let's just fire her up and see what she does, shall we? See what performance we get. Okay, so everything's connected. It's on. I can probably just, you can see there, you can see the light emanating from underneath. It's quite, actually, looks much brighter, much more higher temperature than 4000. I'm not sure. Anyway, we'll check that in a minute. So yeah, here's the clean AC power source. It's a solid state big piece of test equipment that's over there, controlled by a PC interface next to me. It's running at 245 volts AC, 50 hertz. It goes up to 350 volts at 500 hertz. But you need a clean, stable supply with a proper sine wave to do any measurements, because anything else, you do any other measurements, if there's lots of distortion in the mains, or the mains voltage upside down, up and down, you end up with a problem. And it's connected to the WT210 precision power meter, which you can see up the top of the picture, right? So let's check the voltage. We've got 244.65 volts AC, and we're pulling 6.106 watts. So it is drawing 6 watts from the mains, okay? So when I turned it on, it was 6.5 watts to start with, but it's going to vary. And we've got a power factor of 0.53, which is pretty bloody awful. Commercial power factors need to be over 0.95 for commercial lighting, but for domestic lighting, you're not going to worry about that. So we're taking 6 watts, right? But if I put the volt amps, which is the product of the voltage and the current, Now this is the imaginary power, they call it. There's plenty of videos on it on there, but if I go to VA, you can see it's taking 11.44 watts or 11.44 volt amps. That's the sum of the current and the voltage up together. So a current equivalent to that power is circling around the mains all the way back to the substation and back, burning energy or creating heat in the cabling of the distribution system, right? But the only bit you're paying for is that one. Now the trouble with the smart meters, by sending a message to your smart meter, if you have one, in the future they can then bill you for that instead, because they are capable of just measuring VAs, and VA is how commercial customers pay for their power. They don't pay on watts. So at some point there's talk of us moving to VAs instead of watts, so you'll be paying for 11.4 watts for this bulb. If this had power factor correction in the bulb, then you'd be paying for 6 watts, and then when you press this button this would read 6.5 watts. Okay, so it'd be a very little difference between VA charging and watt charging, but clearly you in a commercial environment, if you had a warehouse, you wouldn't want to deploy these because you'd be paying for 11.4 watts of electricity instead of the 6 real watts. So you'd be paying for the imaginary power or the volt amps, alright? So a power factor of 0.53, which is pretty bloody awful, and the current in milliamps is 46.71. What does it say on the packet? So they're saying 52 milliamps, but we're actually taking 53. Oh no, sorry, 46.68. So it's taking less power at the higher voltage. So if we knock that down to 225 volts, so we're going down in voltage. Watch the birdie, 225.0. So I'm reducing the mains power supply to 225. Bang, there it goes. Let's just check it. That's not, it's the peak. Yeah, 225, alright. So we've gone down, we're still 6 watts, and the current is not that one. That one, 48. So it's pretty similar actually. Yeah, so it's a 6 watt light, but they've rated it for 5.5 for some reason. Let's see what we've got coming out of the power supply, shall we, in terms of DC voltage driving our LEDs. I have to be a bit careful here because I don't want to spoil my own day while making your day with this superb video. Aha. Right, so what voltage have we got coming out of this thing? As my head's in the way, I do apologise, but that's what my head does. Okay, so she's running at 46 volts. So there's about 15 LEDs in each chain. In series there's 30, isn't there? So 46 volts, yeah, so 15 LEDs per chain. Alright, 2 chains of 15 then. 46 volts it's going out, and if I just change the voltage on the input, so I go back to 245, actually let's have a laugh, let's go down to 190. Yeah, didn't see any change there. Yeah, 46 volts, so it's regulating okay, so let's go up 245 again. Yeah, so we've got a power factor of, let's put the power factor back on there again so you can see it, 0.53, that's at 245, so if we change to 225, do you see the power factor go up at the lower voltage? So the power factor is better at 210, so let's try, our mains is 215 to 245 generally, that's the actual specification of the mains as far as the power generation boards are concerned. What actually happens at your property is another story. Let's go 230 then, let's go to the 230 nominal, and we've got 0.54, so it's not great. Okay, so the final thing is just let's have a look at the light coming off it, shall we? Let's have a quick look. Yeah, without the lights on it does look a bit more like 4000. Yeah, so here I've got the spectral radiometer. GLF is my company, another one of my companies. We do various things to do with plants and plant lighting. We do synthesis measurements and all the different stuff. But what we're interested in here is transmittance. Okay, so the transmittance, what that will do is just measure the difference, and what we're going to check is the actual how much of the light this really opaque diffuser is costing us. Okay, so it's a really rough and ready measurement, but it is very valid actually. So if we go into transmittance, okay, so now let's put a standard diffusing reflector here. So we'll just put that piece of paper there. Okay, and then we'll do measurement 1 and measurement. Let's move it so you can see it. The only light that's in here, up here, I'll put a photo of this in here, is the light suspended directly above the unit, alright? So this light, our bulkhead light, is directly above. There's a distance of 18 inches, or, oh, let's measure it. Let's not do a guess. Let's do the right thing. Right, so between the light, there's a ruler, steel rule, one that end, 49. It's 50 centimeters from the entrance to the spectroradiometer to the actual lights, and at the moment, as I say, the cover's not fitted. So all I'm going to do is do a measurement, one measurement first, reference measurement, and then we're going to put the cover back on, and then we'll test it again. So there's the source, look, you see that? So you've got a lovely peak of blue, and then there's not much in the, I suppose there's some in the turquoise and violet, and then you can see it's running down to 662, so it's a standard white 4000 LED, right? So that's the source. Now if I just clip this thing back on the top, boom, boom, yeah, and then we go reference, and if we just do a measurement, clearly there is no nothing in between. I haven't put the filter back on or the diffuser back on, so you can see it tracks, and it's down at minus 0.4%, so it's pretty much hanging around near zero. Transmittance percentage, there is that blue line, and it's minus 0.2%, 0.1%, so that's the actual calibration mark. Okay, so now if I just clip this back on, this is this bit going back on, right? And then we're going to clip that back onto the light without moving it, like that. So it's back on now. So now we're running with the diffuser fitted, and if I go reference, now you can see. So if we just turn the lights, I'm not sure if you'll be able to see better with the lights on or off. What do you think? But if we zoom in on this slightly, this display, you're going to get a much better view. Alright, so the attenuation there, you can see on the top one, the actual new line of the light is that black line imposed on here. So you can see you're losing a lot of the light on that very thick diffuser. It's a very thick diffuser, and 23% over the lifetime of your, on average, say between 20 and 30% of your light is going to be lost by the diffuser. It'll be bounced around inside, never come out of the light. So it's a 5.5 watt light, and you are probably 2 watts of that is being lost in transmittance losses due to the filter. So the filter's costing you probably up to a fifth of the electricity spent is lost in the actual cover, and that's always true. If you have a clear glass one, it's 3 or 4%, a really good one. If you have this type of material which is not carefully, the opacity isn't really carefully controlled, and this is really too thick plastic, and it's just using a lot of light. So that's where the efficiency is going on this light, is actually in the diffuser itself. And if I go to percentage, you can see at all the different frequencies we've got the losses. Okay, so that's what we've got. So if we go back to the reference again, turn that one, you can see there's the transmittance, that blue line. So a lot being lost in the filter. Not good, eh? So when you look at your lights and you've got these things like with tubes or just LEDs without you know, just basic bare emitters, they're much more efficient than ones that have got fairly poorly controlled diffusers. And as soon as I saw that diffuser, I thought, you know, that's quite opaque and it's really thick, and it will block out a fair amount of your light. If you just turn that into a sheet of plastic, a flat sheet of plastic, and rather than the domed white thing, clear plastic, you'd get a lot more light out of it. You can see from this graph here how much light is being lost. You'd get the basically very near to the top peak rather than this very attenuated. So it's not a good use of power. If you think all the households of the UK putting such lights in with very low or fairly low photometric efficiency, not good really. Yeah, as an interesting an interesting exercise. I was just going to show you, this is a normal white LED lights, and the high CRI colour rendering index is the ability to render all the colours. You can imagine if you had this colour here, this particular piece of plastic with this colour on, or you wouldn't get the same depth of colour range of rendering. The reds wouldn't be as deep, and the violets and everything else wouldn't be right, and the actual colour, the apparent colour of something, will be depending on how much of that light at that waveform there is, and the reflectivity at those waveforms of that material, not the reflectivity at the core value of the peak reflectance of the material in terms of chromaticity, you know, the chroma, the colour wavelength of the light. So let's just try this actually, because if I just turn off this, I'm going to turn this light off here. That's my computer. Turn off the bulkhead light, so that's off, and then turn on. Clearly these will be much brighter, but these are the Philips CRI 0.95, so they're very good colour rendering lights. It makes all the colours look much nicer. When you're working in the environment, it's much nearer to daylight, you get the thing. So, and you can see high CRI. Do you remember on the other one, if I was the other spectrum ended about here? So the bottom display is the actual high CRI 95, the top one is the standard 4000, and you can see the difference in the illumination. There's not a lot of difference up at the blue end, is there, or the green. There's a couple of funny peaks around about 550, something like that. But the main difference, it looks like, is down at the red end. Look at the shape and the size of the red curve to the right. You can see there's a lot more of the deeper red colours between 600 and 725. There's a lot more red there, so that's where your nice deep reds and your colours come from, the reds themselves. You can see, so you've got a lot less energy down in the deep reds, so this light won't render the reds very well. Yeah, so all in all, for $6.99, I suppose it's not bad. It's not waterproof. There's no protection for the varistor in there. I'd like to see that varistor fitted, because it will get blown up. If you have a surge at your house, this will get destroyed. I'll have a quick look at the chip and see which chip they use. If I can easily find it, I'll put something on the end of this video. So carry on watching if you're an electronics engineer. There might be something at the end. If not, if you could just subscribe to my subscription link down there. And yeah, thanks for watching. Not a bad light, small and expected. Not waterproof, generally okay, but you know, you could do better, I think, for the money. Get a genuine OSRAM one.